In today's lesson, we're going to talk about translations. So it says, now let's take a look at translations on the coordinate plane. Similarly to what you did in your previous lesson, you are going to be doing an investigation. So it says, use the graph below to answer the following questions. So you're going to use this picture that you see here of quadrilateral A, B, C, D, and then A prime, B prime, C prime, and D prime. And you're going to answer questions 1 through 5. They are very similar to your previous investigation. I want to know what happened from the original A, B, C, D to A prime, B prime, C prime, D prime. You're going to list the coordinates of A, B, C, D and the prime figure below. I would suggest listing them side by side so you can take a look in number 3 at what happened to the coordinates. You're going to go over what properties were preserved. Remember, preserved means stays the same. And you're going to be testing out the same 4 things: orientation, shape, side length, and ankle measure. And then you're going to officially name the transformation. So at this point, please pause the video and try the investigation on your own, questions 1 through 5, then resume the video to go over the answers. Okay, now that you've tried the problems on your own, let's go over the answers. So first of all, when you're just looking at the graph, describe what happened. I see that the original ABCD shifted or slid 6 units to the right and 4 units down. So then in number 2, I listed my original coordinates there. A is negative 4, 7, B is negative 3, 4, C is negative 5, 0, and D is negative 8, 3. And I listed the new coordinates. A prime is 2, 3, B prime is 3, 0, C prime is 1, negative 4, and D prime is negative 2, negative 1. Now this one, the rule does not pop out as nicely as it does in some of our other transformations, but there still is something special going on. If I take a look at the X value here, negative 4 became 2, that went up 6. Negative 3 became 3, that went up 6. Negative 5 became 1. Negative 8 became negative 2. So for all of those, you add 6 to X. So I put in number 3, 6 is added to the X coordinate. Then if I take a look at the Y's, 7 became 3, that's taking away 4. 4 became 0, that's taking away 4. 0 take away 4 is negative 4, 3 take away 4 is negative 1. So I took away 4, subtracted 4 from the Y coordinate. Now at first you might think that seems kind of out of nowhere, but it isn't. If I look and see 6 added to the X coordinate, and I go back up and see what actually happened to the shape went to the right 6 units. And which axis runs left and right? The x-axis. This is the x-axis. So if I go right or left, I'm either adding or subtracting from my x value. Again, the 4, not coincidence either. If you look at what we described to happen in number 1, the image went down 4. So we had a down movement. The vertical axis is a y-axis. So it makes sense that you would subtract 4 from the y values. And we'll talk more about that as we move forward. What properties were preserved? All of them. Remember what orientation means. If I look at what was originally labeled, we went A, B, C, D to the right. And when I see the new one, A prime, B prime, C prime, D prime, still to the right. So orientation is good. Shapes the same, side length the same, ankle measure the same. So officially, the name of this transformation is a translation 6 to the right and 4 down. So I always tell my students to try to remember the cha-cha slide for the translations. Translation is a slide. So you slide to the left and slide to the right. You also, though, can go up and down. Okay? So now that we investigated that, let's take a look at some examples and exercises together. In exercise 1, it says the grid below contains points A, negative 4, negative 2, B, negative 1, 3, and C, 2, negative 1. Okay? So in part A, it says translate point C to its image point C prime by moving it along the vector. So I want you to underline that. That maps A to B. Give its coordinates below. So since I underlined vector in green, I'm going to trace my vector over here in green. This is a vector. You see it has an endpoint and an arrow, okay? So what a vector does is give you the direction and technically the magnitude, which is length. It's going to tell you how to move. So I'm going to take and count what this vector is showing me. It's showing me I'm going to go up and right. That's where the arrow is pointing. But to be specific, we'll count 1, 2, 3, 4, 5, it went up. And 1, 2, 3 to the right is how it moved. So we want to make sure we move C prime, or C, the same way to get C prime. So that would be up 5 and right 3. And that's all based on the vector that was given to us on this image. So again, it's showing us up and to the right, but we can count the blocks specifically to know how to move. And now for C, we'll do the same thing. We'll go up 1, 2, 3, 4, 5, and to the right 1, 2, 3, and C prime ends up there. So here we'll put C prime, and we'll put it at 5 and 4. That's the new location. Now, B says, how can we describe the effect of this translation on where the image is located compared to the original point? So, the image is 5 units up and 3 units to the right of the original point. So I wanted to show you an example where they're not going to tell you up, down, right, or left. They're just going to give you the vector, and then you're going to have to look on the coordinate plane to figure out what the vector is telling you to do. And all you need to do is count the boxes of how it moved, and it's going to move in the direction that the vector is pointing. Now let's go on to exercise 2. Triangle ABC is graphed on the grid to the right. Its vertices have coordinates of A, -6, 2, B, -1, 7, and C, 3, 2. In the first part, question A, we're going to translate triangle ABC 6 units to the right and 5 units down. We'll then label it with primes and state the coordinates of the new image. So I'm going to take a step ahead of that, and I'm actually going to write down the original coordinates as well again, just so we can see where everything goes. So A was at -6, 2, B is at -1, 7, and C is at 3, 2. And then we will say where they end up. So I'm going to take each point and count 6 units to the right and 5 units down. So we'll start at point A. We'll go 1, 2, 3, 4, 5, 6 to the right, and then 1, 2, 3, 4, 5 units down. That puts A prime right there at 0, -3. Then we'll do the same for point B. We'll count 6 units to the right, 1, 2, 3, 4, 5, 6, and then 5 units down, 1, 2, 3, 4, 5. So there's B prime. That's at 5, 2. And then we'll do the same thing for C, 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5 down. There's C prime. C prime is located at 9, -3. And then we can connect our shape. And we know that all the properties were preserved. So when we're done, we should see the same orientation, the same shape, the same side length, and the same angle measure. It should look like it just slid over and down to a new position. So, how could you have found the coordinates of the image vertices using addition and subtraction instead? Explain. So this is going to connect us back to what we were doing in the previous investigation. I want to think about what each of these things means. So if I'm going 6 units to the right, which axis runs right and left? That's the x-axis. So any movement right or left is going to be a change in the x value. So if you mean 6 units right, which is translating, we'll write translate, 6 units right, that means, since you're going to the right, that you add to x. Okay? And then if we look similarly to the part where they're translating 5 units down, Which axis runs up and down? The y-axis, right? So if you're making any up or down change, you're actually changing the value to the y value. So here, translating 5 units down, since you're down, that means you subtract from y. So in our case, we want the original xy to change to x plus 6 because we went to the right 6 and y minus 5 because we went down 5. So this would be an example of your algebraic rule. You could use that rule to get your coordinates first and then go plot your points. So just to make a connection back to what we did in the investigation, here, I'll kind of come over here to the side. Remember, we had 6 added to the x coordinate. So I would tell you that xy went to x plus 6. And then we had 4 subtracted from the y coordinate, so y minus 4. Because in this one, we went to the right 6 and down 4. So now you can see several examples of translating on the coordinate grid. And that concludes your lesson on translations.